Here's problem 1111. A particle of mass 0.1 kilograms and speed 5 meters per second collides and sticks to the end of a uniform solid cylinder of mass m equal to 1 kilogram and radius big R equal to 20 centimeters. If the cylinder is initially at rest and is pivoted by a frictionless axle through its center, what is the final angular velocity in radians per second of the system after the collision? This is kind of similar to the last problem. We're going to approach it in the same way. One thing we can say right off the bat is that angular momentum will be conserved. So our initial angular momentum will equal our final angular momentum. And we do have an initial angular momentum here. It's all supplied by this moving mass m. And we're going to calculate it about some point, which is the center, the axle of the cylinder. So our radius from that point is actually r. We have a line of action for the movement of this little mass m, and its distance from the axis that we're considering is r. And it's moving at a speed v. So our initial angular momentum of this system is mvr, which is actually mv big R, which in this case is going to be 0.1 times 5 times 0.2, or 0.1 kilogram meter squared per second. So that is our initial angular momentum, and since it's conserved, that is also our final angular momentum. Good to know. Well, our final angular momentum is equal to our final moment of inertia times our final angular velocity. So if we know our final moment of inertia, we can solve this for our final angular velocity, and that's going to be our plan. So let's find our final moment of inertia. In the final analysis, we have the cylinder like this, and it's got this point mass connected to it, and the moment of inertia of this system is the combination of the two. So the final moment of inertia is the moment of inertia of the mass m plus the moment of inertia of the cylinder big M. For the mass m, it's going to be a point mass m r squared, because the distance r away from the axis, this r right here, plus the moment of inertia of the cylinder is going to be 1/2 big M r squared. In terms of numbers, this is going to be 0.1 times 0.2 for 20 centimeters squared plus 1/2 times 1 times 0.2 squared. And that is equal to 0.024 kilogram meter squared. So that is our final moment of inertia of the system. So now, using this equation right here, we can say that our final angular velocity is going to equal our final angular momentum divided by our final moment of inertia. And that's going to be equal to 0.1 kilogram meter squared per second over 0.024 kilogram meter squared, and that's going to equal 4.167 radians per second. So that is our final angular velocity of the system about the center axle of the cylinder, 4.167 radians per second.